And welcome back, Mindsetters. Hope you had a nice little break there. You went and did whatever you had to do, so you're back, ready, and paying attention. Because Mindsetters, we've got in this next section. I need you guys to get your questions in, otherwise we cannot help you. So on that note, this is where I'm going to quickly hand over to Tracy, who's going to continue the rest of the show.
Thank you, Ty. Yay. Okay, last section for today, we're going to look at acceleration. Acceleration can only be a vector. Because when we look at acceleration, it's defined as the average acceleration is the change in average velocity divided by the time taken. It's the rate of change of velocity. It can also be the rate of change of speed, but we don't often look at it in that context. It's rate of change of velocity. Acceleration is a vector. It has to have a direction, okay? Which means either when something is accelerating, it is going to be getting faster or it is going to be getting slower. If it is getting faster, we normally consider it a positive acceleration. If it is getting slower, it's a negative acceleration. Though that isn't always the case, grade teens. Please be very careful. I don't want you to learn that positive acceleration means it's always getting faster. Negative acceleration means it's always getting slower. No, it doesn't. It depends on all the other factors around what you've chosen as your positive direction. Okay, so it's really important that we don't get stuck on saying, well, negative is definitely slowing down. No, it's not. Okay, so if we look at the equation, average acceleration is change in velocity over change in time. Acceleration, which I'm hoping you all remember, has the symbol little a. Okay, so now what we're looking at is change in velocity, delta v over delta t. Velocity is meters per second, time is seconds. Okay, so together they give us our unit of acceleration, which is meters per second squared. Okay, meters per second squared. We will only deal with average acceleration, grade teens. At school level, we only deal with linear motion with regards to our equations. We just don't, you guys just don't do the maths, and that's okay. You would need to be doing varsity level maths to cope with something that's not linear. And by not linear, I mean if we have a situation where the acceleration is constantly changing, that is a problem for us because we just don't have the maths at this point. And that's okay. So we will always have a situation where we keep in the maths simple and we deal with situations where we have constant acceleration. If the acceleration changes, so we have a situation where, and this happens when you're driving in a car, the car speeds up, slows down, speeds up, stays constant, slows down. Each of those are different sections of motion. When we get to equations of motion, we're going to deal with all of those separately. Okay, we don't deal with them all at once because we just don't have the maths. And that's okay. I'd rather not teach you that maths. Now, what that means is, we've got this sort of theory behind acceleration. I actually have a couple of questions for you guys, because I think Ty, you said it's not really too many questions coming up on Facebook. You need to make sure you get this, grade 10s. It doesn't really matter how silly you think the questions are, because this is your basis. I said to my grade 10s when we started today, this is going to get asked what we call incidentally when you get to grade 12. So by the time you get to grade 12, we sort of expect that you know what this means, that you understand acceleration, that it doesn't have to be explained to you again. In grade 11, you're going to do Newton's laws. We don't want to have to explain this again to you. It's done. It's over. You should know. It becomes your foundation. Just like in maths, we expect you to be able to go, well, 2 plus 2 equals 4. Okay, without the use of a calculator, though, for some of us, we know that's scary. Okay, so let's look at the first question I have for you. An athlete is accelerating, nice and appropriate considering Olympics and Paralympics, okay, is accelerating uniformly. Uniformly means constant, okay? Constant. From an initial velocity of 0 to a final velocity of 4 in 2 seconds. Calculate his acceleration. And then they say to you, let the direction that the athlete is running in be the positive direction. Why did we tell you this? Because I haven't said to you that he's running left, that he's running right, that he's running. I haven't said that to you. So what we mean is he's running in the positive direction. Forward, hopefully. Okay, so what did they say to us? They said to us that my initial velocity is 0. Now, this is probably a new symbol for you guys. Okay, velocity with a little I means initial. Initial's where I began. Okay, is 0. My final is 4. And it took 2 seconds. Change in, whenever we deal with change in any situation, grade 10s, means that I take the final of that component minus the initial of that component. So, if acceleration is change in velocity over change in time, it means that we have to do final velocity minus initial velocity divided by time. Now, you're going to see this equation in different formats a lot over the next couple of weeks. And final velocity was 4. Initial velocity was 0. Time was 2 seconds. So we get 4 divided by 2. So it's 2 meters per second squared in the positive direction. Okay. Hopefully this makes sense. We've got a positive acceleration, which means he was getting faster. Yay, it's what we wanted. Okay, 2 meters per second squared is not particularly fast acceleration, but hey, it's a good acceleration. Grade 10s, you shouldn't ever be asked to convert this to kilometers per hour squared. Okay, that I've never seen, so don't try and do it. It becomes a little bit more complicated than what I showed you earlier. Okay, next question. Come on, there we go. A bus, we have another bus, which accelerates uniformly. Now notice what we've done here, from 15 meters per second, so my initial velocity is 15 meters per second, to a final velocity of 7. So grade 10s, what's happened? The bus has slowed down. If we now make a decision in terms of direction and we go, well, let's make the bus's original direction positive. So if the bus is going forward, we're saying that's my positive direction. The bus is slowing down, which means we have to apply a force in the opposite direction to which the bus is moving. We are going to get a negative acceleration. So the acceleration experienced opposes the way the bus is moving, okay? Because he's probably applied the brakes. Very important thing to have. Okay. Time is 4 seconds. Acceleration is v, okay, delta v over delta t. Let's write it vf minus vi. Now, grade 10, some of your teachers might not insist on writing vf minus v over delta t. I think it's a very good habit. Just because it reminds you that we've got to go final minus initial. Very important, okay? So my final was 7. My initial was 15. And I get 4. Now, if you go 7 minus 15, we get negative 8 divided by 4. Negative 8 divided by 4 is negative 2. Grade 10s, we don't leave our answers as negatives. We need to write it as a positive answer with a direction. Okay? Negative answer, not acceptable. So it's 2 meters per second squared. In the opposite, actually no, there's a shorter way to write that now that I'm thinking about it. We could say in the opposite direction to the bus's motion, but man, that gets a bit long. Let's not do that. 2 meters per second squared backwards. Because the bus is going forwards, I hope. Okay, very, very important. If I needed to use this acceleration in a calculation a little later on, which you're going to see, I use the negative value. So when I use that value in a calculation, I use the minus. When I get it as an answer, I take the minus away and I describe the direction in words. I'm hoping you'll get that. Any questions yet, Ty?
Not
No.
as yet.
Have I made them all fall asleep?
No, I think what happens that, and I've had this happen to me before, where they actually tell me that no, Ty, we're actually just following along, so don't worry.
I'm having a good day. Brilliant. Well, actually, I have another question, so it's fine. Okay. I did this one deliberately because of what I told you earlier about looking at the motion in separate sections. An aeroplane accelerates uniformly, constantly, from an initial velocity of 10 meters per second to 200 meters per second in 10 seconds. There is a change in motion. I have to consider the second section separately. It then accelerates uniformly to a final velocity of 240 in 20 seconds. So this 200 here actually goes into both. Okay? So we're saying that we have 10 seconds. We have a 10-second period where the aeroplane goes from 100 meters per second to 200 meters per second. Then it takes, once it reaches 200, it changes its acceleration, and now it goes to 240 meters per second in 20 seconds. Okay? And the first part of this says to me, calculate the acceleration of the aeroplane during the first 10 seconds, which is everything I have in blue. So, first 10 seconds, my initial velocity was 100. My final velocity was 200. And my time, 10 seconds. We want acceleration. So acceleration is change in velocity over change in time, which is final minus initial. I'm hoping at least some of you know this equation already. And so we're going to go 200 minus 100 divided by 10. So that's 100 divided by 10. 10 meters per second squared. That's okay. I mean, but it is, if we now multiply by 3.6, it's going from 360 meters per second to 720. That's kilometers per hour. That's fairly fast, just so you know. Okay, it's still slower than the speed of sound, though. Okay, then calculate the acceleration of the plane during the next 20 seconds. What's the trick here, grade 10s? The initial velocity in the next 20 seconds is 200. This was the trick. For you to realize whenever we change motion, there's always something on the boundary that's common. Okay? Always something that's common. So my initial velocity was 200. They said to me that the final goes to 240. And time is 20 seconds, okay? So we want acceleration. So acceleration is change in velocity over change in time, which is, I'm going to put it here because I keep running out of space. Okay, and the final was 240. My initial was 200. And it takes 20 seconds. 240 minus 200 is 40. So that's 20. It's only 2 meters per second squared. Huge difference. Huge difference in acceleration. But there's nothing wrong with that. Okay? Big acceleration for the first 10 seconds, almost ready where it needs to go. Smaller acceleration. It's just, the same sort of thing happens when we drive in a car. So, before we end off, what do you need to remember from today? Speed is a scalar. Speed is independent of the displacement, doesn't matter about the direction. With speed, I'm completely concerned with the actual physical distance traveled. Change in distance over change in time, measured in meters per second. A velocity is a vector, almost like speed, but it's a vector because now we need direction. And when we look at the length the path length that we need, it's a straight line from beginning to end. We don't care about all the curvy bits. And direction, I need to know which way it went in, okay? And then that's change in displacement over change in time, which is delta x. Added to that, we then have acceleration, where acceleration is also a vector. Acceleration is change of velocity over change in time, also needs a direction. Now, I left this out in this question. This should be 2 meters per second squared forwards. And the other one was 10 meters per second squared forwards. I'm saying forward because I don't know which way the plane's going, and I'm assuming it's going forward. You don't really want it to accelerate backwards. That would just be scary if you're actually sitting in the plane. Okay, so you want it to go accelerating forwards. Sometimes will be a bit nice when I actually give you the direction. Okay, and I think that's a good place to end. And next week, we're going to look at instantaneous speed, instantaneous velocity, and hopefully do some ticker tapes.
All right.
Yeah.
So, as you guys heard, make sure I'm hoping you guys were paying attention and wrote the stuff down, because as you know, it's very important for your guys' exams. And I just want to say shout out to everybody who's been on the page. Thank you so much for participating. And on top of that, I also want to send this quick shout out to Liberty. Thank you for sponsoring. And Mindsetters, I cannot stress again, make sure you guys access the page. Use it. It was made for you guys. Talk to each other. If you see a mindset in trouble, as I always say, help them out. Don't just leave them hanging. If you know the answer, share it. That's the point of the whole platform. But on that note, Mindset is this where I say, see you next time. Cheers.